So now let's take a look at what goes on in the pipeline registers. So we have the following instructions in our pipeline: branch equal, add I, add load word, and store word. And the question is, which of the pipeline registers have reg write set to be true? So to take a look at this, let's figure out where are the instructions in the pipeline. So the newest instruction is going to be the one we just fetched. It's going to be in the new beginning of the pipeline, so that's branch equal here. So in instruction fetch pipeline stage, we'll have branch equal. Then in the next stage, instruction decode, we'll have the add I. Now what does it mean for this instruction to be in this pipeline stage? Well, it means the instruction's been stored in this pipeline register. And you can see this here. The instruction that we loaded from the memory before is now stored into this pipeline register. The next instruction is going to be execute stage, that's add. It's going to be in this pipeline register. Then we're going to have the load word. It's going to be in this pipeline register. And then finally in write back, we're going to have store word, which is going to be in this pipeline register. Okay, let's go see if reg write is going to be true for these. So for the first one here, for branch equal, is reg write going to be true? Well, branch equal doesn't write back. So it's never going to set reg write to be true. And in addition to that, it hasn't been decoded yet. So we only figure out if we should set reg write after we go through the control logic and decode the instruction. So we haven't gotten there yet, so we don't have any way to store that. And in fact, if you look at this stage here, there really isn't a pipeline register. The instruction isn't stored on this stage. We just store the PC and use that to get at the instruction. So the answer is it's not in this stage. Okay, let's take a look at the next one. In the instruction decode for this add I, is its reg write going to be true? Well, add I does write, so it's going to write to the register file, but it hasn't been decoded yet. So all we've got right here is just the raw instruction. We haven't gone and decoded the instruction yet. We need to go through the control logic. So this pipeline register here, it doesn't even have a reg write in it. So that one's not going to be true. Let's go on to the next one. How about execute stage, our add instruction? Is reg write true? Well, yes. Add does write back to the register file, and we've done the decode stage, so now we're going to be storing reg write as true here in this pipeline register. So that one's true. How about the next stage? Is reg write true for the memory instruction here, or for the load word instruction in the memory stage? Well, again, load word takes data from the memory and writes it to the register file, so it does write to the register file, and we've passed the decode stage, so the reg write bit in this register file, the reg write bit in this pipeline register will be true here. So that one's also true. And finally, how about the last one for our store word and write back? Well, store word doesn't write back to the register file. It stores data into the memory, but it has been decoded. So here we do have a register write bit, but it's not going to be set to true because the instruction in this stage doesn't write back. So this is what we get for that problem. So let's take a look at what goes on with pipeline control signals. So here's our pipeline. And we've got three instructions: add, load word, and branch not equal. And we want to go through and we want to figure out what are the control signals that are used in each stage. The execute stage for choosing what goes into the ALU, where we're going to put the results back, what the ALU operation is. For the memory, what happens with the branch, the memory write and read signals, and for the write back, what happens to the mem to reg mux here, and the register write control here. So let's take a look at add. So add's an R-type instruction, and what's it going to do? Well, in the execute stage, we're going to take our results from two of the register files. So the mux here that we have, our ALU source, is going to select the register file. And then when we go on to the write back stage, we're going to take the result of that and we're going to send it around and use that to write into the register file. So for our mem to reg mux here, we're going to pick the results that come from the ALU for the output there. Now, how do we tell to write? Well, in this instruction, when we decode our control in the write back part of the pipeline register, we're going to store our value for register write. So it's going to go through these register files and through the pipeline registers, and when the instruction gets to the write back stage, it's going to cause it to go ahead and write back. How about for load word? Well, load word's an I-type instruction, and so that means that when we get into the execute stage, we're going to take the results from the immediate, which was stored in the pipeline register down here, and one of the register files up here. The operation we're going to do is add, because we're calculating the address. When we get over here to the end of the memory stage, we're going to store the data we read out into the pipeline register after that stage, and then when we go to do write back, we're going to select that value. So not the result of the register file, which comes through here, but the result of the memory. So we're going to select that because the control is going to go through here. So here's the control for the memory part. It's going to be stored in the memory part of the pipeline, and it's going to tell the memory to read. And then when we're done, we go on to the write back. We're going to take the results of the memory and we're going to write it back. And just as we saw before, that write back control is generated by the control, goes through all the pipeline stages, and finally comes back and writes and controls the register file to write. How about for branch equal? Well, for the branch instruction, it's an I-type instruction, so we're going to take two registers here. We're going to do a subtraction in here. Now, when we do this, we're going to take the 0, and the 0 is going to go into the branch logic, and we need to have the other part of the logic which tells us the instruction. And so that's going to come from the control. The control is going to decode this, put it in the pipeline register, and we'll use the pipeline register later when we decide whether or not we want to take the branch. We then send this result back to choose the next PC. Now, if you look at this, there are a bunch of don't cares going on here. We don't care which register destination we choose here for writing things back, because we're not writing back, and we don't care whether we choose the memory output or the register output for writing back, because we're not going to write back. So in each of these cases, we don't care what we set to those because we're not going to use them. We're still, however, going to set the write back, and in fact the write back is going to be set to false because we're not going to write into the register file when we're done.